Good morning, class. Today we are going on to section 17.3, area between a curve and a line. Now I will start off with example 13 first, which they want to find the area that is shaded over here. Now you can see that the whole area here will be the area under the curve. Okay, now what I need to do is that I will take the whole area here minus the area of this rectangle. Okay, now before that I need to find out what's the coordinates of A and B first. In order to find out the coordinates of A and B, I need to solve this and this equation simultaneously. So I equate them both. After I form the quadratic and I solve, I will get 4 and 1. So this is 1 and this is 4. So how to find the area of this shaded region will be under the curve, I integrate 1 to 4, this particular expression dx, then I minus the rectangle here, which is, this is of length 3 units, this is of length 8 units, so 3 times 8, which will give me a 24 for the rectangle, and we will minus it off. Okay, so I do the necessary integration, I substitute in, I minus 24, I'll get a 4.5 unit square. Now class, alternatively, you know that the area under the line, I can also integrate from 1 to 4 with respect to 8. This is the equation of the line, and in order to get the area under the line, I have to integrate 8 from 1 to 4. So the area of the shaded region can also be gotten by, you integrate from 1 to 4 the curve, minus you integrate from 1 to 4 8. That means the area under this particular line. Okay, so if you integrate this, the answer will still be 32 minus 8, which is 24 here, which is the same as this. So it's up to you whether you want to minus off the shape or you want to minus off the integration of this line from 1 to 4. The answer will be the same. Okay, so after I do the necessary manipulation, you realize that the answer is also 4.5. Alright, so let me just repeat this. You can do so by finding the area under the curve minus a rectangle, or you can do it by another way, area under the curve minus area under the line. To find the area under the line, you integrate from 1 to 4 with this particular line equation. Okay, so there are two ways to do this. Now, if you look at page 135, they will give you a summary. Okay, so let's take a look at page 135. They have these two here. If you want to find this red area, is curve minus line. So you integrate a to b, the curve equation or the curve expression, minus a to b, the line expression. Okay, now let me just repeat. You can do so, you can also do it by getting the area under the curve minus the area of this trapezium. Okay, it is also okay, but if you want to use the trapezium, you got to know the y coordinates as well, so that you can find the length of the parallel sides. Okay, so either way will do. I repeat, you can find area under curve minus area under line by integration, or you can find area under curve minus area of trapezium. Okay, you can also find the area of the red region here. Both ways are okay. Bear in mind that if you want to find the trapezium, you got to know the y coordinates of these 2 points. Okay, now likewise, if I want to find this red area, now this is the other way around. Can you see that I have to take the trapezium minus this area under the curve? Okay, let me just show you. If I want the red area here, I need to find area of the trapezium minus this area under the curve, then I will get the red area. So I integrate a to b, the expression for the line, minus a to b, the expression for the curve. I will get this. Okay, alternatively, you can get area of trapezium minus area under the curve. You can also get the area A. Alright, you can also get the area A. Okay, so both ways. Alright, now I will move on with example 14. Let's take a look at example 14. I will show you both. Now class, you don't have to use both ways. Sometimes one way is more convenient for the other in a particular question. Sometimes both ways work just fine. Okay, so you decide for yourself. So let's take a look at example 14. I want to find this green area here. So I will take the area under the curve, the whole thing, okay, minus the area under the line. This whole thing, I will get the green area. So in order to find the coordinates of these 2 points, I solve the equation simultaneously. I will get x2 and x negative 1. So I know this is negative 1 and this is 2. Okay? Alright? Now, if we use area under the line, the green one here, I take integration of the curve minus integration of the line. I manipulate it. I'll get 4.5 units squared. Okay? Now, if you want to use the area under the curve minus the trapezium, you need to find out the y coordinates. Okay? You just sub into this equation. Minus 1 put here, you have 8. 2 put here, you have 5. So we know this is length 5, this is length 8. So the area can also be found by integrating from negative 1 to 2, the curve expression, minus half times half times height. This is the height of the trapezium. These are the 2 parallel sides, sum of the 2 parallel sides. I get this, I will also get the same answer as 4.5 units squared. So it's up to you to choose either this method or this method to use to find the area of the shaded region. Okay? Alright, next we move on to example 15. Now for example 15, we want to find the area of this particular shaded region. Okay, but note that this area is under the x-axis. That means it's below the x-axis. So we have to be careful down here. Now in order to find these 2 points of intersection, I have to solve the equation simultaneously, and I will get x negative 3 over 2 or x2. Then I proceed to find the y coordinates. So I will know the coordinates of this point and the coordinate of this point. And this point, we're lucky it falls right on the x-axis, which means the y coordinate is 0. So the area required. Now I need to find from here to here. Okay, what do you mean by that? That means I need to find this whole area here that is under this curve. I will integrate from negative 1.5 to 2 here, x squared minus 4 dx. This is area under curve, bounded by the curve and axis. But mind you, it's below the x-axis, so I must put a negative sign. Okay, then I minus off. I minus off what? I minus off the area of this triangle. This triangle will have height 1, 3, 4, and of base 3.5. So the area of the triangle will be half times base times height. I will get this 3 and 1 over 16. Okay, 3 and 1 over 16. So don't forget, because it's under the x-axis, I have to put a negative sign, so I will manipulate. Okay, I will get 7 over 48 units square as the answer for this shaded area. Now, let's say you do not want. You say, I don't want to find this triangle by using the triangle formula. So what you can do is you can integrate this line, okay, in order to get this area. Okay, that means you got to integrate from negative 1.5 or 1.5 to 2, half x minus 1. Half x minus 1 is this line, but because this is below the x-axis here, I need to add a negative. So when you manipulate this, you can see that the area of the triangle is also 316, which is the same as this, 31 over 16. Okay, so both ways will work, but you have to be careful. Now this example is quite a difficult one because both areas are under the x-axis and you have to put a negative. Okay, a lot of students will forget that and then they will get a wrong answer. So please be careful over here. Alright, now next we go on to example 16, which is the last example. Okay, now the question says that you are to find the coordinates. Let me just check the question again. The first question is to find the equation of the tangent. They want to find the equation of this tangent. okay, this tangent here. Now y is this, so you find dy dx. Now you know that at this particular point P, x is 5, we sub in, we get the equation, the gradient of the tangent. Now when x is 5, y is 12, so the coordinates of P is this. Okay, so equation of tangent, I can find y minus 12, so on. So this will give me the equation of the tangent. Y equals to 8x minus 28. Okay, now second part, they want to find the coordinates of R. Now, R is the point whereby the tangent meets the x-axis. That means when y is 0, I substitute in, the coordinates of R is 3.5, 0. Okay, now last part, they want us to find the area of the shaded region PQR. Now, the area of the shaded region is this small region here. Now, I want you to take note that the area of this small region is the area under the curve from 3 to 5 minus the area of this triangle. Okay, area under the curve minus area of this triangle PRS. So, I will use integration from 3 to 5, the curve, minus area of the triangle. I manipulate it, I will get the answer as 1 2/3 unit square. Now, alternatively, you can also find the area of the triangle by integrating from 3.5 to 5. That means the area of triangle can be found by integrating from 3.5 to 5. Okay, then you integrate with respect to this particular expression. This is the expression for the line, equation of the line. So this one, you will also get a 9. Therefore, it will coincide with this and you will get the same answer. So it's up to you to find the area, whether you want to use the curve minus the triangle or the curve minus area under the line, because the triangle and the area under the line will be the same value. Okay, so this is the last example for section 17.3. Now, what homework are you supposed to do? You are supposed to do this homework on the foolscap paper. Exercise 17.3, 1A, 1B, 1C, 2B, 3, 5, and 7. Okay, now remember, you are to check your homework, do your homework first before you check the answer that's on the next video. Do not just copy, because it will not do you any good. Alright, so that's for section 17.3.